This video highlights how to use the Enumerate Adsorbates panel within Schrödinger's materials science suite. It demonstrates how to construct adsorbate structures, specifically focusing on the molecular or dissociative adsorption of gas phase molecules onto a solid substrate. I'll demonstrate a trimethylphosphine molecule adsorbing on a titanium dioxide surface. Substrates can be either periodic systems, such as surfaces, or non-periodic entities like molecules or nanoparticles. In the Enumerate Adsorbates panel, the substrate and gas molecules are loaded. A reactive atom is designated for each component, with the default selection being the most exposed non-hydrogen atom for the substrate and the most exposed atom for the adsorbate molecule. If multiple atoms share equal exposure, the atom closest to the cell center is chosen. You can either use the filter to restrict the reactive atoms to a specific type or manually select them in the workspace. When multiple substrate atoms are present, you have the option to adsorb at on-top, bridge, and/or hollow sites. Additionally, checking the Enumerate option allows for the rotation of the gas molecule. The project workspace displays the enumerated output, with zero-order bonds indicating new bond formation. These structures are suitable as initial geometries for subsequent adsorption energy calculations. Using either quantum mechanical or machine learning force field methods, the adsorption energy can be calculated and the adsorption free energy can be plotted.